Hello students, today we will learn mechanics to prepare for Edexcel AS and A-level mathematics year 1. The book we shall be using is Pearson year 1 AS statistics and mechanics. So today we will learn mechanics. We will study chapter 8 today. While studying chapter 8 modeling in mechanics, we will solve some problems also. So stay tuned, hit like and subscribe and watch the video till the end. Thank you. So before we start, we need to understand what is mechanics. So mechanics is the study of effect of forces on objects. Okay. So the first thing we need to understand about mechanics is that whenever a force acts on a body, it will cause the body or object to change its motion. If it's already moving in a certain direction, then maybe it will change its direction, maybe it will come to rest, or maybe its speed or its velocity will increase. So basically mechanics is the study of motion of objects under the action of force. So whenever we study mechanics, we come across a situation where we have to model the motion of objects, how the object is moving. So if the object is moving to some linear path, maybe the object is moving in a curved path. So understanding the model of a motion of an object is critical to understanding the motion of the object. Okay, so let's dig right into it. So today we will solve some problems from chapter 8. First we will try questions from exercise 8a. So let us solve some problems from exercise 8a to understand how we can model and how we can use the models to understand or to solve the problems related to mechanics. So this first question number 1 from exercise 8a. The motion of a golf ball after it is struck by a golfer can be modeled using the equation h is equal to 0.36x minus 0.003x squared, where h is the height of the golf ball above the ground and x is the horizontal distance traveled. So this h is equal to 0.3x. This is the model, this is the equation of the height expressed in terms of the horizontal distance. Okay, so this will be used by us when we solve this problem. So the first question is find the height of the golf ball when it is struck. So first thing we have to find is the height of the golf ball when it is struck. So when it is struck, at the instant when the golf ball is hit by the golfer, at that particular instant the distance of the golf ball from the golfer is 0. Essentially x is equal to 0. So at the instant when the golf ball is struck by the club, the distance is 0. So this can be very easily solved. We just have to put 0 in place of x and we will get the height. So the solution for problem 1 is, so we just simply substitute 0 in place of x and we get h is equal to 0.36 times 0 minus 0.003 times 0 squared. So it is equal to 0. So the height will be 0 when the golf ball is struck. So that's the first answer to the first problem. The second one is we have to find the horizontal distance. We have to find the height of the golf ball when it is at the horizontal distance of 100 meters. So when the golf ball is 100 meters away from the point of strike, from where it was struck. So to solve this problem, we have to replace x by 100 and we will get the height of the golf ball when the golf ball was 100 meters away in the horizontal direction from the point where it was struck. Okay, so very simple. H is equal to 0.36 times 100 minus 0.003 times 100 squared. So it is equal to that's 100 times 0.36 is 36, minus square of 100 is like 10,000. So 10,000 times 0.003 times 10 raised to the power 4. Okay, and we will get something like 36 minus so the height of the golf ball will be 6 meters at a distance of 100 meters from the point where it was struck. Now use the model to predict the height of the golf ball when it is 200 meters from the golfer. Okay, now we have to use this same model to predict the height of the golf ball when the distance of the golf from the golfer is 200 meters, horizontal distance from the golfer. Okay, so that's part B. Okay, so again we will replace x by 200. Okay, so height will be 0.36 times 200 and minus 0.003 times 200 squared. (72) minus 3 into 10 raised to the power minus 3 times, that's 200 squared is 40,000. Okay. It's negative 48. So this negative sign indicates what? This negative sign indicates that our model has broken down, that our model cannot process it any further. Just try to think of it intuitively. For example, if the golf ball was initially here and the golfer struck it like this, it made a kind of a parabolic arc. So it was struck from here and it went here. Okay. Now what happens is, as the golfer hits the golf ball, it jumps up, lobs up, and makes kind of a parabolic path, and then ends up on the ground again. So it started from 0 height and ended up on 0 height. So during its journey, during its motion, it acquired some height, some maximum height, but it started from 0 and ended to 0. It cannot go below 0. It cannot have a negative height. Okay, it started from ground and ended on ground. So the model, this negative sign indicates that during somewhere along this journey, somewhere along this length, this model broke down, and this model could not accurately predict. So this model has its limitations. So we have to find what is the limitation of this, what are the limitations of this model. So comment on the validity of this prediction. So this comment can be, we can get this comment by checking the values of x for which height is equal to 0. If height gives us a negative value, it means that our model is breaking down. Okay, so we will find the values of x for which the model is valid. Okay, so to find the values of x for which the model is valid, we simply put h is equal to 0. So when we put h equal to 0, it becomes 0 is equal to 0.36x minus 0.003x squared. Okay, so let's take it to the next page. So we multiply both sides by 1000 and we get 360 x minus 3x squared is equal to 0. So x 3x is equal to 120 minus x is equal to 0. So x, there are two values, x is equal to 0 and x equal to 120. So the model is valid for these two values. The model is valid between these two ranges. So h is equal to 0.36x minus 0.003x squared. This model of prediction of the golf ball motion is valid from x equal to 0 to x equal to 120. Okay, so that's our first problem. So let's move to question number 3. So let's solve another problem. The motion of a basketball as it leaves a player's hand and passes through the net is modeled using the equation h is equal to 2 plus 1.1 x minus 0.1 x squared, where h is the height of the basketball above the ground and x is the horizontal distance traveled. So let's draw a little, let's draw a diagram. For example, there is a basketball hoop, something like this. Okay, there's a basketball player. Now the ball follows this kind of trajectory, parabolic kind of a trajectory. Okay, so initially the ball moves up, then comes down and goes through the hoop. Okay, find the two values of x for which the basketball is exactly 4 meters above the ground. So the first part A is we have to find the two values of x where the basketball is exactly 4 meters above the ground. So to find the two values of x, we simply put h is equal to 4 in this equation. So these are the two values of x for which the height will be 4 meters. So basically now that's part one of this. That is the solution to part A. For part B, this model is very valid from 0 to x less than k, where k is the horizontal distance of the net from the player. Given the height of the net is 3 meters, find the value of k. Okay, so this model is valid till the ball reaches the hoop. After the ball enters the basketball hoop, its motion does not follow this model. The motion of the basketball does not follow this model. So we have to find the distance k, which is basically the distance of the basketball player from the hoop. So let's dig into it. So to find K, we put H is equal to 3 in this equation. So when we put H is equal to 3, we get So when we put H is equal to 3 in this equation, we get a quadratic. We can factorize it. Like this. So the factors will be so after the basketball enters the hoop, this model is no longer valid, because when the basketball enters the hoop, it does not follow a parabolic path. Okay, so that's why this model will not be valid for x greater than 10. If we put x greater than 10, this model will lose its validity. So that's question number 3. Now as another example, a car accelerates from rest to 60 miles per hour in 10 seconds. The motion of the car is given by, the motion of the car can be expressed by this formula: d is equal to kt squared. Where d is the distance in meters, k is some constant, t is time in seconds. So now when t is equal to 1 second, the distance traveled by the car is 13.2 meters. Okay, use this model to find the distance traveled when the car reaches 60 miles per hour. Okay, and write the range of the values of t for which the model is valid. So to find the distance traveled by the car when the speed reaches 60 miles per hour, we first need to find the value of this k. And to find the value of this k, we need to know a value of d and t, which is given in this part. So that's what we will do. When t is equal to 1, the distance traveled by the car is 13.2 meters. So 13.2 is equal to k times 1 squared. So k is equal to 13.2. So that's a constant. Now use this model to find the distance traveled when the car reaches 60 miles per hour. In the problem statement, it is written the car accelerates from rest to 60 miles per hour in 10 seconds. So the total time to reach 0 to 60 miles per hour is 10 seconds. So we will use this 10 seconds as time. The value of k we have already found, and the same formula will be used, and we will find the total distance it took for the car to reach from 0 to 60 miles per hour. So d is equal to kt squared. So d is equal to 13.2 times time is 10 seconds squared. So d is equal to 13.2 times 100, which is 1320 meters. So that's the total distance the car took to accelerate from 0 to 60 miles per hour. Now, write the range of values of t for which the model is valid. The model, as you can see in the problem statement, is valid for t from t equal to 0 to t equal to 10. That's it. So let's solve some examples related to exercise 8D. Let's solve some problems related to exercise 8D. So, exercise 8D, question number 1. A man walks from his home along a straight road to a shop with a speed of 2.1 meters per second and walks home again at a speed of 1.8 meters per second. He then jogs along a straight road from his home to the park with a speed of 2.7 meters per second and returns home at a speed of 2.5 meters per second. The park, the man's home, and the shop all lie on a straight line as shown in the diagram. Park, home, shop. Okay. And from left to right is the positive direction. Take the positive direction as shown in the diagram and state the man's velocity on the journey from his home to the shop. So velocity on the journey from his home to the shop. So this is already given in the question. The man walks from his home along the straight road to the shop with the speed of 2.1 meters per second. This is the velocity of the man from his home to the shop. That's 2.1 meters per second. So that's the answer to part A. Displacement from his home when he reaches the shop. So the displacement is given in the diagram. It's 500 meters, and since it's from left to right, so it's gonna be positive 500 meters. So that's plus 500 meters. The displacement, velocity on the journey from shop to his home. From shop to his home, that's in the negative direction, and the velocity is given in the question. The velocity on the journey from shop to his home. So velocity walks home again at the speed of 1.8 meters per second. So that's negative 1.8 meters per second. Velocity on the journey from his home to the park, that's negative direction. And the speed is also given, that's 2.7 meters per second. Displacement from his home when he reaches the park. Displacement from his home when he reaches the park. The displacement from home to the park is 750 meters in the negative direction, so it's negative 750. Velocity on the journey from park to his home. Velocity from park to home is in the positive direction from left to right, so it's positive, and its value is given in the question. That's 2.5 meters per second. So that's it for question number 1 from exercise 8D. Now let's try another question. Question number 2 from exercise 8D. The velocity of the car is given by v is equal to 12I minus 10j meters per second. Find the speed of the car the angle, the direction of the motion of the car makes with the unit vector I. This velocity has been given to us in vector form. By means of vector form, we mean that it has been expressed as a sum of its x and y components. This unit vector 12, this part 12i and this part minus 10j represents x and y components of this velocity vector. And by x and y components, we mean what? For example, if I want to draw this vector, this velocity as a vector, if I want to draw this velocity as a vector, so in the x direction, it has 12 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this velocity vector is 12 units long in the positive x direction. So it will be given by 12i. I represents 1 unit in the positive x direction. Similarly, this minus 10 represents 10 units in the negative y direction. This j represents the y coordinate, the vertical component of this vector. So minus 1, 2, 3, 4, 5, 6. So somewhere here, this minus 10j will lie. So combined, if we sum these two vectors to get the resultant vector, so this is the vector v, velocity vector. It is the sum of vx and vy, the horizontal and vertical component. The vx is 12i and vy is minus 10j. So it is the sum of these two vectors. By head to tail rule, vx plus vy is equal to v. So this is the velocity vector. Now the velocity of the car is expressed in vector form. Find the speed of the car. We know the speed of any object is a scalar. So if we take any object that has some velocity, which means that it has some speed also. Only if we ignore its direction, then the magnitude of the velocity will represent its speed. So the speed of the car in this case will be the magnitude of this velocity. It will be the magnitude of this velocity. It will be the magnitude of this vector 12i minus 10j. It will be the magnitude of this vector. So how can we calculate the magnitude of this vector? For example, as we have already drawn this plot, we know this vector is 12 units long in the x direction and 10 units long in the y direction. So what is the total length of this vector? What is the total magnitude of this vector v? So this total length can be found by using the Pythagoras theorem, which is very simple. The magnitude of v, which we can call is the speed, is given by square root of vx square plus vy square magnitude. So this will give us the speed of the car, which is 12 squared plus 10 squared is equal to square root 344. So that's the speed of the car. Now the angle direction of motion of the car makes with the unit vector I. The angle the car makes, the direction of the motion of the car makes with the unit vector I means the angle the velocity vector makes with the positive x-axis. The unit vector I represents x-axis or x component. So the direction with the unit vector I can very easily be found by taking the ratio of taking the ratio of these two, vertical component and the horizontal components, like this. We know that this is a right angle triangle. We know that these three vectors Vx, V and Vy make a right angle triangle, and we have to find this angle. We have to find this angle. So it can be found by simply taking a tangent. So tan, let's call this angle theta. Tan theta is equal to minus 10 over 12. That's 5 by 6 negative. That's negative 5 by 6. So we can simply take the inverse function of tan, and we'll get the value of theta. Well, theta is equal to tan inverse 5 by 6. So this will give us the value of theta. So that's this way we can find the direction of motion of the car. Basically, it will give us this angle. This angle will give us the direction of motion of the car. So that's question number 2 from exercise 8D. So question number 3 from exercise 8D. The acceleration of a motorbike is given by A is equal to 3i minus 4j. It is expressed in vector form. It is expressed in vector notation. 3i represents the x component of acceleration, and 4j represents the y component of the acceleration. So we have to find the magnitude of the acceleration and the angle direction of acceleration vector makes with the unit vector j. So basically what we have to find is the magnitude of the acceleration as well as the angle which the acceleration vector makes with the j vector, unit vector j. So unit vector j means we have to find the angle the acceleration vector makes with the y-axis. Okay, so first we find the magnitude, which is very simple. We know that if we have a vector expressed in vector notation, we simply if we have a vector expressed in vector notation, that is its x and y components are given. This I represents the x component, this 4j represents the y component. Then we can very simply get the magnitude of the vector by using the Pythagoras theorem. So which is equal to 3 squared plus minus 4 squared, which is equal to 9 plus 16 is 25. Square root of 25 is 5. So the acceleration is equal to 5 meters per second squared. Okay, that's the easy part. Now we have to find the angle the direction of the acceleration vector makes with the unit vector j. So to find the angle which the acceleration vector makes with the y-axis, we simply on the side draw this vector. Try to draw this vector. For example, this is the xy plane. Okay, so we have to draw this acceleration vector by using its x and y components. The x component is 3i. So let's say 1, 2, 3. That's a point of 3i, and minus 4j. Minus 4j is in the negative y direction. So 1, 2, 3, 4. So this is the point where these x and y components combine, and so the direction of this vector will be something, so that so the direction of this so the vector resultant acceleration vector will have its direction something like this, where this is the x component and this is the y component. Okay, so we have to find the angle. This acceleration vector a, let's call this a, makes with the y-axis, and we normally measure the angle from in the counterclockwise direction. So we will measure this angle from the positive y-axis. So it will be something like this. Okay, it will be something like this. Okay, so this angle will be this plus this small one. Okay, this small part, so this small portion. So, and this small portion is equal to 90 minus this part. So this is equal to, let's call this angle phi. Phi is equal to 90 minus, let's call this angle theta. 90 minus theta. Okay, so we have to find theta. We can very easily find theta by using the x component and y component of this vector. Okay, so theta can be found by, theta is equal to tan inverse 4/3. Okay, tan inverse 4/3. We can use the negative notation, but since we have already drawn the vector, so we simply take whatever the value of this and put a negative sign with it. Okay, so it will give us this theta value. So its value will be given by, so this will be equal to 53. So that will be the angle will be minus 53. So phi will be 90 minus 53.1. The difference between this phi will be 90 minus 53.1, which will be equal to, so the angle measured from the So that's the answer to this question. So let's move forward. So that's question number 4. So girl cycles from A to B and then from B to C. The displacement from A to B is 10I plus 3j kilometers. The displacement from B to C is minus 7I plus 12j kilometers. So basically both these displacements are expressed in vector form. Okay, vector form means where x and y components are individually given. Okay, we have to find the magnitude of the displacement from A to C. Okay, we have to find the magnitude of displacement from A to C. Okay, we have to find the magnitude of the vector AC. We have to find magnitude of vector AC. We have to find this. Okay, and find the total distance the girl has cycled in getting from A to C. Okay, so we have to also find the total distance. Okay, not displacement, total distance the girl has cycled in getting from A to C. So we have to first find distance AB and add to it distance B to C. So this is also what we have to find. And third part is work out the angle AC makes with the unit vector I. also we have to find the angle vector AC makes with the horizontal x-axis. Okay, so we have to find theta as well, direction of the vector AC as well. So first we will find vector AC. So vector AC we can find by using the head to tail rule. So what will be the vector A? Vector AC will be we will place the vector we will simply just sum these vectors and we will get the vector AC. So it's very easy. Vector AC is equal to vector AB plus vector BC. So it's like 10I plus 3j, this is vector AB, plus minus 7I plus 12j. So it will be equal to 10 minus 7 is plus 3j, 3 plus 12 j. So it will be equal to 3I plus 15j. So this is the resultant vector AC. This is the resultant vector AC. Okay, this is the resultant vector AC. So we have to find the magnitude of this vector. We can very easily find the magnitude of this vector by using the Pythagoras theorem. So there is this question mark and we'll solve it right here. So the Pythagoras theorem applied to this vector AC will give the x component is 3. So 3 squared plus 15 squared is like 9 plus 2 to 5 is 2, 3, 4. Square root 2, 3, 4. That's the distance. That's the magnitude, or that's the displacement from vector A to C. Okay, square root 2, 3, 4. That's the magnitude of the displacement from vector A to C. Okay, so that's expressed in meters. Now the second question is we have to find the total distance traveled by the girl while she cycled from A to B then B to C. Now this will be equal to the magnitudes of vector AB and vector BC is given by square root of 10 squared plus 3 squared plus magnitude of vector BC is square root 7 squared plus 12 squared is equal to 109 square root plus 49 plus 144 plus 49 plus 144 is equal to 193. That's 193. Using a calculator, we can very easily find these two to get the total displacement from the total distance the girl traveled from while moving from A to C. Okay. Now the last part, work out the angle AC makes with the unit vector I. So the vector AC makes with the unit vector I. We already calculated the vector AC. The vector AC was given by (3i) plus 15j. Now the x and y component are given. x and y component are given, we can very easily find theta. Theta is given by tan inverse y over 3 over x. That's 5. That's tan inverse 5. It will be given, its answer will be, and the angle will be 78.6. So the theta will be 'That's what the vector AC, that's the angle vector AC makes with the unit vector I. So that's problem number 4. Now the exercise 8D is finished. We will try some examples from the exercise, mixed exercise. So we will try the last question first. A plane flies from P to Q, then from Q to R. The displacement from P to Q is 100I plus 80J. The displacement from Q to R is 50I minus 30J. Find the magnitude of displacement from P to R. Find the total distance plane traveled in getting from P to R. Find the angle between vector PQ makes with the unit vector J. So, a plane. We have finished exercise 8D. Now we will try some questions from exercise from the mixed exercise. So I will try the last question first. Question number 9. A plane flies from P to Q and then from Q to R. The displacement from P to Q is given by vector 100I plus 80J. The displacement from Q to R is given by 50I minus 30J. The displacement from find the magnitude of displacement from P to R. We have to find the magnitude of the displacement from P to R. We have to find the displacement from P to R. Okay. So basically we have to find the vector PR, its magnitude. That's the first part. Find the total distance the plane has traveled in getting from P to R. Second part is we have to find the distance the plane traveled while going, the total distance plane traveled while moving from PQ to R. Okay, so what we have to find is PQ, the displacement PQ, magnitude of the displacement PQ, then add into it the magnitude of the displacement QR. That's the second part we have to find. And find the angle of the vector PQ makes with the unit vector J. Also we have to find phi, the angle the vector PQ makes with the vertical x-axis. Okay, so the first part is very simple. We have to find the vector PR and then get its magnitude. So vector PR is the sum of vector PQ and vector QR. So PQ plus QR is equal to 100I plus 80J plus 50I minus 30J, which is equal to 100 plus 50 is 150I plus 50J. So the magnitude of vector PR is equal to, this is vector PR. The magnitude of vector PR is equal to is given by, can be the magnitude of vector PR can be calculated as 150 square root of 150 squared plus 50 squared, which is equal to 158.11 meters. So that's a displacement of that's the magnitude of displacement of vector PR. The second part, the distance PQ plus QR. The second part, it can also be found using the Pythagoras formula. Can be found using the Pythagoras formula, Pythagoras theorem. So it will be as the magnitude of the vector PQ will be given by PQ will be given by 100 squared plus 80 squared square root plus QR will be given by square root 50 squared plus 30 squared. So the total So the total distance the plane traveled while going from P to Q and then Q to R is 186.3 meters. Now the last part, the angle the vector PQ makes with the vertical the unit vector J. So basically vertical axis. So it's simply we can use the Pythagoras to get the value of theta, and in that theta we will subtract that theta from 90 and we will get the distance from the angle measurement of the angle from the vertical y-axis. So it is given by something like this. Theta is equal to tan inverse the vertical component of this vector PQ is 80 horizontal component is 100. So that's so the angle which this vector PQ makes with the unit vector y or unit vector j, we know that unit vector j represents the y-axis. So the angle this vector PQ makes with the unit vector j or y-axis is 90 minus theta, 51.34. That's the answer. Now what we have here is the motion of cricket ball after it is hit until it lands on the cricket pitch can be modeled using the equation. Now we have been given a model of a motion, which is h is equal to height is equal to 0.1 times 24x minus 3x square, where h is the vertical height of the ball above the cricket pitch and x is the horizontal distance from where it was hit. Find A, the vertical height of the ball when it is at a horizontal distance of 2 meters from where it was hit. We have to find the vertical height of the ball when it is at a horizontal distance of 2 meters from where it was hit. So in this part, we will put x is equal to 2. We will put this x is equal to 2. The second part, the two horizontal distances for which the height of the cricket ball was 2.1 meters. In this part, we will put h is equal to 2.1 in this equation. Okay. Given that the model is valid from when the ball is hit to when it lands on the cricket pitch, find the values of x for which the model is valid. We have to find the values of x for which the model is valid. Work out the maximum height of the cricket ball. We have to find the maximum height of the cricket ball as well. So first, we will solve the part A. We will put x is equal to 2 in this equation. H is equal to 0.1 times 24 times 2 is 48 minus 2 square times 3 is 4 times 3 is 12. That's 0.1 times 36. That's 3.6 meters. So the horizontal distance of 2 meters from where it was hit. The vertical height of the ball when it is horizontal distance of 2 meters from where it was hit is 3.6 meters. So this is h. So that's part A. For part B now. The two horizontal distances for which the height of the ball was 2.1 meters. So we put h is equal to 2.1 in this equation. Okay, we put h is equal to 2.1 in this equation. So h is equal to 2.1 is equal to 0.1 times 24, 0.1 times 24x minus 3x squared. We take this 0.1 on the left hand side, it will become 10. So the left hand side becomes 21 is equal to 24x minus 3x squared. So this is kind of a quadratic equation. It will become minus 3x squared plus 24x minus 21 is equal to 0. So as we can see, 3 can be factored out, so it becomes x square. We factor out minus 3 instead of 3. X square minus 8x plus 7 is equal to 0. So its factors will be something like this: x square minus 7x minus x plus 7 equals 0. So can be written as x times x minus 7 minus 1 into x minus 7. So x minus 1 and x minus 7 equal to 0. So the two values of x are x is equal to 1 and x is equal to 7. So the two values of x for which height of the ball was 2.1 meters is x is equal to 1 and x is equal to 7. That's the answer to question number for question B. Find the value of x for which the model is valid. Given the model is valid from when the ball is hit to when it lands on the cricket pitch. So we have to find the values of x for which the model is valid. So we put height is equal to 0. It will give us values of x for which the model is valid. So for part C we put h is equal to 0. Is equal to 0.1 times 24x minus 3x squared, or we can solve it like 3x times x minus 8 is equal to 0. So the two values of x, so the model is valid from x is equal to 0 to x is equal to 8. These are the two values of x for which the model remains valid. Within the bounds of these two values, the model remains valid. Work out the maximum height of the cricket ball. The maximum height of the ball. To find the maximum height of the ball, we will differentiate this equation with respect to x. We will differentiate height with respect to x. Okay, so it will give us the first derivative. Okay, it will give us the first derivative. And by putting the first derivative equal to 0, we will get the extreme value or maxima or minima value. If it is positive, to find the maximum height of the cricket ball, we will differentiate this equation. To find the maximum height of the cricket ball, we will differentiate this equation h is equal to 0.1 times 24x minus 3x square with respect to x. We will differentiate this equation with respect to x and equate it equal to 0. So let's see. Let's erase a few stuff from here. So h is equal to 0.1 times 24x minus 3x squared. So we'll differentiate this with respect to x. So dh over dx is equal to 0.1 times 24 minus 6x, and we will put it equal to 0 to get the value of x. So for which the height will be maximized. So 24 minus 6x is equal to 0. So 6x is equal to 24, x is equal to 4. So when we put x equal to 4 in this equation, we will get the maximum height. So we put x equal to 4 in this equation. In this equation, so h is equal to 0.1 times 24 times 4 minus 3 times 4 squared. So it is equal to 0.1 times 24 4s are 96 minus 3 times 16 is 48. So it's 96 minus 48 is 48 times 0.1 is 4.8. So the maximum height of the cricket ball is 4.8 meters. So the maximum height of the ball is 4.8 meters. So this is the solution of this problem. I hope you will be able to solve these problems on your own from now on. So that's it for today. Chapter 8 is finished. Tomorrow we will do chapter 9, 10 and 11. So that's it for today. I will upload the video. Hit like and subscribe and share with friends. Thank you.